So it is day 17 in geometry, and we're starting unit 3 today. Today is Monday, November 3rd, and it is day 17. So, first of all, in this unit, we have built up quite a few things. In unit 1, we learned about lines and angles. So we had one line, and then we did 2 lines that made an angle. Unit 2, we added a third line and made triangles. In unit 3, we're going to add a 4th line and make quadrilaterals, okay? So quadrilaterals, if you've never heard this word before, I want you to look at the first part of the word. Quad. Does anybody know what quad means?
3.
Not 3. Tri means 3, like triangle. 4. Quad. Let's write that. Q-U-A-D. Quad means 4. That is a prefix. It's something that comes at the beginning of the word, quad. You might see this in a couple of other circumstances. Quadruplets. That means 4 babies in your belly at the same time. A quarter. 4 quarters make $1. Let's see. Any other? Let me think. What is it?
A quartet.
A quartet. That's 4 singers. 4 people singing at a time. That QUA prefix means 4. That's what it refers to. So a quadrilateral is going to be a shape with 4 sides and 4 angles. Now, polygon, we're going to look at the first part of the word poly.
One.
Not one.
Many.
Many.
Yeah.
Good. Poly means
Yeah.
many or multiple, more than one. So I'm going to write many / multiple. I can only think of one example for poly, like polyamorous. If you're polyamorous, you have multiple partners.
Mm-hmm.
All I can think of. I don't know if there's any other poly examples.
Polytheism.
Polytheism, yes, that means you believe in multiple gods. I want to say, I feel like polydactyl is a thing.
Polygamy.
What is it?
Polygamy is like they have more than 2 wives.
Ooh, okay, see, I didn't know. We're learning things. So, quad is 4, poly is many or multiple, more than one. And we're talking about shapes, polygons. So let's actually talk about what a polygon is. So a polygon is a closed shape. Closed meaning it's not open. It means all of the sides connect together. It can be colored in. A closed shape. And it is made with straight sides and angles. You cannot have a curved side. Closed shape made of straight sides and angles. So polygon just means shape with many sides, with more than one side. A quadrilateral is a type of polygon. A triangle is a type of polygon. A square is a type of polygon. You could think of lots of polygons. Let me ask you this though, based off of this definition, is this a polygon? No. This is a circle. Circles are not polygons because it does not have any angles or straight sides. It's just one long curved line. Circles are not polygons. I'm going to write that. Not polygon. Ask you about this one. I'm drawing this kind of randomly. Is this a polygon? Yes, it's a polygon. All of my sides are straight. It's got angles and it's a closed shape. I could color it in. This is a polygon, yes. What about this? Is this a polygon? Why not?
It's not closed.
It's not closed. This is an open shape. This is not a polygon. So we get the idea. Not a polygon. Good. Good. So we have to have straight sides, angles, and the shape must be closed. So I'm going to leave this up for a moment to let everyone copy it down. And we are going to talk more specifically about quadrilaterals. And I'll start a new page for that next. So this is page 1. And while we're waiting, let's see. The second polygon that I drew here, or I guess the only polygon I drew, how many sides does that have? Can we tell? How many sides do we think that one has? 13. 13. I got 13. Here, I'll show you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 sides. Little sneak peek at one of the things we'll talk about later. Special way that we can name polygons by their sides, by their number of sides, is we just put the number of sides in front and then we add gon. This would be a 13 gon. That's what that's called. 13 gon, because there's 13 sides. They were really creative when they came up with that. So that's just a little FYI for your information. See a few more people still writing, so I'll wait just a minute. I'll pause this before we move on to the next. All right, so we know the basics of polygons. They must be closed shapes. They must have straight sides and angles. And we learned all about triangles in Unit 2. So now Unit 3, we're going to be focusing mainly on quadrilaterals, but we will talk about other polygons as well. Today's focus will be quadrilaterals. So I'm going to write page 2 for my notes. And, all right, day 17, let's continue. Geometry, Unit 3. We're going to talk about a few different types of quadrilaterals. So we're going to draw kind of a diagram here. To do that, I'm going to get out a ruler. And I'm going to start by drawing a big 4-sided shape on my paper. I'm going to take up almost the whole page. Maybe half the page, not the whole page. So I will go like this. I'll draw one line. I made that about 12 centimeters. Then I'll do another line. A big like rectangle here. Right at the top, I'm going to write not huge because I want to give myself some space in here. We're going to write quadrilaterals. Q, U, A, D, R, I, F. So everything that we draw inside of this box is a quadrilateral, which means it has 4 sides and 4 angles. Sides and 4 angles. Okay. Now, inside of our quadrilateral box, I'm going to draw the next thing, and I'm going to take up most of the space inside of here. What I'll do is I will start with a tilted line and make it about 10 centimeters. Draw a straight line at the bottom. I'm going to make that one maybe 12 centimeters. Make another one at the top that's 12 centimeters. I'll connect these two, and they should be about 10 centimeters again. So make like a tilted shape where opposite sides are equal and my lines are parallel, meaning they're going at the same angle. Does anybody know what shape we just drew? Anybody? Anybody know? Hints I'll give you is that the sides are parallel. That's my hint. I'm going to mark that they're parallel by drawing some arrows. So I'll do 2 arrows here, 2 arrows on the opposite side. And then 1 arrow on the other opposite sides. 1 arrow, 1 arrow. Now, not only are the opposite sides parallel, but they're also equal. So we're going to put tick marks as well. So 2 tick marks on one opposite pair, 1 tick mark on the other opposite pair. Does anyone remember the name of the shape? Parallel is the hint. I bet you've heard of this before.
Parallelogram?
Yes, it's a parallelogram. Good. So I'm going to write another little title that says parallelogram. Parallel. So parallel, and then O-gram. O-G-R-A-M-S. So we're putting parallelograms inside of quadrilaterals because they still have 4 sides and 4 angles. But now we have a couple of extra things. Opposite sides are equal and parallel. So we're going to write opposite sides are equal and parallel. This is the symbol for parallel. It's just 2 lines right beside each other like that. Equal and parallel. Opposite angles are also equal. I guess we could write that too. Opposite sides are equal and parallel. Also write opposite angles are equal. So parallelograms. Those are the features of that. Now inside of this parallelogram, we're going to draw another shape. And that shape, I don't want it to take up the whole rest of the space. I'm going to have it take up this corner here. We're going to draw a rectangle. So I need 2 opposite sides that are equal. Those opposite sides are parallel. The only thing that's different now is we will have 4 90-degree angles. So I'm going to draw my rectangle up and down so that I have room for the next thing. Okay, rectangle. Didn't measure, but it looks like I made my longer sides about 7.5 centimeters long, and then my shorter sides about 3.5. If you're trying to make it like mine, it doesn't have to be. So we want to mark all the same things that we did on the parallelogram for a rectangle. I know that my opposite sides are equal. So 2 tick marks on the long sides, 1 on the short sides. I know that they're parallel. We could do that too. Arrows. Now what we need is 4 right angles. How do I label right angles? With the box. Yes. So we need all 4 corners to have 90-degree angles. So for a rectangle, we see 4 sides and 4 angles. Opposite sides are equal and parallel. Opposite angles are equal. And now all angles are 90 degrees. Before I write that, I'm going to write the name or the word rectangle here. RECTANGLE. Rectangle. 4 90-degree angles. Once you have your rectangle drawn, we have just 2 more little shapes. The next one is going to be a rhombus. Now, a rhombus has 4 sides and 4 angles. It has opposite sides that are equal and parallel. Opposite angles are equal. But it doesn't have 90-degree angles. The angles don't matter. The only thing that's different with a rhombus is now all 4 sides are the same length. So I'm going to pick a length. I'm going to go with about 6 centimeters. And this is going to feel weird, but I'm going to have it overlap my rectangle. And that's for a reason. You'll see. So 6 centimeters. And then I'm going to do another 6 centimeters on up. You want to have an overlap. And then 6 centimeters again. Go out a little. Not perfect, but you guys get the idea. And another 6 centimeters here.
I did that.
Try to make your sides parallel. So if I made my 6 centimeter side here, just slide that ruler down. Try to keep it close to the same angle. It's okay if it's not perfect.
Got a triangle.
Oh no, that's okay. Well, what's wonderful is if you draw a triangle, a rhombus is like 2 triangles. So you could just draw the other triangle.
I don't know.
That's okay. That's okay. So what we'll do is even if your picture is not perfect, we'll still label it the right way. Over here, where it's just the rhombus, we will write the word rhombus. 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 And this time, all 4 sides are the same. So we're going to mark all 4 sides with 1 tick mark. Okay. Sides are equal. That's all the same things above. My opposite angles are equal. My opposite sides are parallel and equal. There's 4 sides and 4 angles. Everything is the same. And then there's one last shape that is a mixture of a rectangle and a rhombus. It's a shape that has 4 sides that are equal and all 4 angles are 90 degrees. What's that? Anybody know?
Know what you're gonna tell us?
It's a square. A square. So a square has 4 sides that are equal and 4 90-degree angles. My square's gonna be really tiny. Because I didn't give myself a ton of room. That's my square. Really teeny tiny. All 4 sides are equal and 4 90-degree angles. So I'm gonna have to write the definition of that off to the side. Didn't give myself a lot of room here. Square is the last shape. And it's 4 equal sides and 4 90-degree angles. This is our little guide to help us remember the different types of quadrilaterals and what makes them unique. Once we've got all this written down, I'm going to show you how we'll use this.
Just a little bit confusing.
A little bit confusing. A little bit confusing. It becomes less confusing when we separate them out. It'll start to make more sense. This is probably the most confusing part. So, a square is a quadrilateral because it has 4 sides and 4 angles. A square is technically also a parallelogram because the sides are parallel to each other. A square is also a rhombus. The 4 sides are equal. A square is also a rectangle. But square is the most specific name. So how it works is we have the category, and as we get smaller, we're getting more specific. So it would be like saying all of you are students. You're all students. Some of you are girls. Some of you are boys. Some of you are in your 20s and you're girls. Some of you are in your 50s and you're boys. It's like the different categories of things. You're all students, but more specifically, you are this, this, and that. It's like a square is the most specific we can get with the quadrilateral. That's the most specific. So, all of that in mind, first of all, are we still writing any of this? Yes. Okay, let me pause this and wait a minute, let everyone catch up. It's a lot to write. All right. So I've just given everybody this worksheet here. Solve for x. Each figure is a parallelogram. So what we're going to do is on my notes, I'm just going to move it down and I'm going to write a little title here. And we're going to focus on parallelograms now. So, all parallelograms. And what we know about parallelograms is that our opposite sides are equal, our opposite angles are equal. So I'm going to pull out from my worksheet number 1 here. I want to look at what my angles are because I have 2 of my angles labeled here. So if I were to look at this parallelogram, let's start by labeling it. I have angle L. What angle is opposite of L? N. So L and N are equal. And then I have M and K. They're not the same. M and K are though, because they are opposite. So my opposite angles are equal. Now we have two options with parallelograms. Here's what happens. I'm going to show you with a piece of clear plastic here. No, let me grab one of those clear sheets of paper real fast. So I'm going to draw on here as a demonstration angle L. So here is angle L. I know angle K is 105. I don't know what angle L is. If I put angle L next to angle K, what do I notice?
The equal 180.
They equal 180. They make a straight line. Any of my angles that are not equal add up to 180. So there's two options. Just like with your parallel lines, parallelograms work the same way. Your options are they either add up to 180 or they're equal to each other. So let's make a little note of that to help us solve the other problems. Parallelograms, opposite angles are equal. I think this might be easier to see with a picture. I know for me it would be. I'm going to draw another parallelogram. Make my first line about 1.5 inches, 1.5 inches. I'll slide it over. Try to keep it about the same angle. Another one that's about 1.5 inches. And then I'm going to connect.
How far would you connect it over?
My top line is almost 2 inches. Almost 2 inches. And then inside of this parallelogram, I'm going to put some labels for my opposite angles. Arc on those, and I'll put 2 arcs on the other pair of opposite angles. All these, we'll put it using the same letters as number 1. So I'll start down here at the bottom left with L, the top left, M, top right will be N, bottom right will be K. Right. Opposite angles are equal. So what 2 pairs of angles are equal here?
L and L.
N.
K.
Good. Angle L is equal to angle N. Is that yellow too hard to see? Yeah, it's a little hard to see. Let me trace over that in a darker color. Is that easier to see?
Yeah.
Okay, good. So angle L is equal to angle N, and angle M is equal to angle K. So those are opposite, they're across from each other. The other sets of angles are what we call consecutive angles. Consecutive means one right after the other. So if I am going to see one right after the other, L and K are consecutive. L and M are consecutive. M and N are consecutive. N and K are consecutive. The ones that are right next to each other. So I'm going to now write consecutive. CONSECUTIVE. Consecutive angles. They're not equal. They add up to 180. So the first example I'll give you is angle L plus angle K equals 180. L plus angle K. What's another pair of consecutive angles I could write? M and N. Angle M plus angle N. What's another pair? K and N. You don't have to write all of them. There's a bunch of different pairs we could write. But basically, the ones that are not equal add up to 180 degrees. So all of that being said, scoot this up a little. Looking at my worksheet now, the angles that I have for number 1 are angle L and angle K. So how can I solve for x using what we just learned? Would I set them equal to each other? Or would I add them up to 180?
What is it?
180. L and K are consecutive. They're not equal. If they're not equal, they add up to 180. So, scoot that up a little more so that I can see it. And I am going to write some workout. Know that angle L plus angle K equals 180. So what do I replace L and K with?
You replace the L with the 8x plus 3, and then you replace the K with the 105 degrees.
Perfect. We're just going to replace L with the value they gave us, 8x plus 3, plus, we'll replace K with the value they gave us, 105. Bring down equals 180. This don't seem so hard now that you know what you're doing. What do we do from here?
Solve the problem.
We solve the problem. So what's a good first step?
Combining like terms.
Combine your like terms. I have 3 and
105.
105.
It'll be 108.
Put those together. That makes 108. Bring everything down. 8x plus 108 equals 180.
You need to subtract 108 from the side.
Subtract 108 from each side. I'll bring everything down. X equals. See. What is 180 minus 108? 72. Good. And what's my final step?
Divide by 80.
Good. Divide by 8. Get x equals
9.
9. 72 divided by 8. Yes, that is 9. We've done it. X equals 9. Very nice. X equals 9. So that's how we would do number 1. All right. To 80. That's what we did for number 1. Those were consecutive angles, not opposite. So let's look at number 2. I'm going to mark my angles. I have F and I have E. Which angle is equal to F?
H.
H, the opposite angle. So angle E is not equal. It's going to be a consecutive angle. So will I set these two angles equal to each other, or will I add them together and set them equal to 180?
7 equal to 180.
7 equal to 180. Good. Add to 180. E 180. What equation could I write now? Perfect. 91x plus 89 equals 180.
You subtract 89.
Subtract 89. Perfect. 91 equals, bring down 91x.
Still 95. Which is 1.
Perfect. Divide by 91 and you get 1. X equals 1. As remember, when we cancel out the 91s, the reason they cancel is because they equal 1. 1x equals 1. So that's our answer. X is 1. Good. Good. Okay, so I would like for you guys to try number 3 and 4 by yourself. And number 4, I want to point something out. I know this is confusing to tell what angle it's labeling. This is angle U. And this is angle P. And same for number 3. This is B. This is A. Okay. So I'm going to leave this up for a minute. Pause the video. I want to set like a little 5-minute timer. I want you guys to try these two on your own. See how we did. Okay. What did you guys get for number 3?
X equals 9.
X equals 9. Did anyone get a different number? Everyone got x equals 9?
What was it?
For number 3. X equals 9. Beautiful. Okay, so how do I set this equation up?
5x plus 15 plus 120 equals 180.
Good. These are not equal. They add up to 180. So I'm going to write the values 5x plus 15. Add it plus 120. And they equal 180. And at this point, we combine our like terms. 15 and 120, what do those add up to? Good. 135. Bring down 5x plus 135 equals 180. What did you do? Good. Subtract
On both sides.
on both sides 135. What is that?
25.
Good. 45. Bring down 5x.
Divided
Divide it by 5. And we get the answer we did. X equals 9. Good job. Perfect. Perfect. Okay, let's look at number 4 then. What do we get for number 4?
Equals 8.
X equals 8. Did anyone get a different number? Did everyone get x equals 8? Okay, that is good. So let's just double check. How do we find that x equals 8?
Negative 5 plus 10x plus 105.
Perfect. Negative 5 plus 10x plus 105. And that is all equal to 180. What'd you do next?
I added negative 5. Negative 5 is 100.
Perfect. Negative 5 plus 105 is just 100.
10x.
Knock down 10x. 180.
Subtract 100.
Yeah. Oh, I wrote the wrong thing.
And divide it by 10.
Perfect. X equals 80. Divide by 10. Beautiful. X equals 8. Excellent. Good job, you guys. Very good job. Okay. Oh, that was number 4. Now, for all of these, we added them up to 180. That's obviously not always going to be the case. Sometimes we will have opposite angles. These all just happened to be consecutive. They all added up to 180. So I want to flip to the next page and see how we feel about ones that might be equal to each other. For example, number 5. These are not consecutive. They don't add up to 180. How is angle R related to angle T? They're equal to each other. So I can say R equals T. What equation could I write?
X minus 2 equals 7.
6. What'd you say? 1 was?
X minus 2.
Oh, does yours have a different number? Mine says 16.
Sorry, not 6.
Oh, you're okay. You're okay. Just want to make sure we're looking at the same thing. So we can do that 16x minus 2 is equal to that 78. Now I wrote R first, but you can do it the other way around. That works.
My line. Oh, no.
That's okay. So 16x minus 2 equals 78. It does not matter which side you put each of the things on. Sometimes I like to have the x in front. It'll give you the same answer. It'll just be written different. So what would I do to solve this?
Add 2 on each side.
Add 2 on each side. Gives me
80.
16x equals 80.
You divide by 16.
Good. Divide by 16.
So your x is equal to 5.
X will equal 5. Nice. So that is really the only big difference that you'll see here. That's how we would do one of those. Okay. all right. So, now, I want you to try number 6 and number 7, and maybe even number 8 on your own. I want you guys to try those while I go make a copy of your exit ticket because you guys grasped onto this very quickly today. This is all I wanted you to learn today, and you've learned it. That's good. So let me pause this. I want you guys to try to do the next few on your own, and I'm going to make a copy of what our exit ticket will be. Let's look at number 6. Number 6, I'm looking at angle W and angle U. Are these angles equal or do they add up to 180? They're equal. Good, they're opposite. So they are equal. So what equation would I write?
2x equals 46.
Perfect. 46 plus 2x equals 46. So I have my equation set up. What would I do to solve this?
Add. Subtract 46.
Yes, we want to subtract 46. We're trying to get x by itself. So let's get rid of 46. And I bet this one threw a bunch of you off. So what's going to happen over here?
0.
0. So I'm going to bring down 2x equals 0.
Divided by 2. X equals 0.
Yes, divide by 2. 0 divided by anything will stay 0. X equals 0. Now, this feels odd, but if we plug this back in, it makes sense. So if I look at my problem, I know that angle U is 46 degrees. So angle W is 46 degrees also, right? So if the value I've been given is 46 plus something, I need it to be equal to 46. Right, it will equal 0 because I need this 2x to be 0. So that 46 is 46. It's the same. So x being 0 makes sense. Awesome. You guys get that one? Good. Little trial and error. That's all right. That's good. We're getting it. Any questions about that one? Okay, let's look at number 7 then. This one may have been the trickiest of all so far. We've got x's on both sides now. What equation would I write for number 7?
Plus 5 equals 17x. Negative 5.
Perfect.
Or minus 5.
We can write either one first, but we know they're equal to each other. They're opposite. So 15x plus 5 equals 17x minus 5. And this is where drawing that line can be helpful. Because what do I have to do different this time to combine my like terms?
They combine 15x and 17x.
Yeah, I need to combine 15x and 17x, but I can't just add them together. What do I do instead?
Subtract.
Uh-huh.
Subtract 15.
Let's subtract 15x from both sides.
Negative 2x.
So I'll bring down my 5 equals 17 minus 15. What does that give you? Say it again.
Negative 2x.
Negative 2. So if it was 15 minus 17, it would be negative 2. Did you subtract 17 from both sides, maybe?
I did, yeah.
Okay.
I mixed it all up.
That's okay. That's okay. So if you do it this way, 17 take away 15, we'll be left with positive 2x.
Yeah, I ended up moving everything over.
I get you. That's all right. We'll keep it, I guess, just how we have it, and we can try it the other way too. Then minus 5 comes down. See if we got the same answer. What would I do next?
You have to add 5.
Yes, let's add 5 to both sides. Ten equals 2x.
Divide by 2.
Divide by 2.
I got the same answer.
Perfect. And we get x equals 5.
I got, so if you do 15 minus 17, you get negative 2.
Yeah, let me do it your way, the other way. So you might have done it differently. I'm going to show you this way too,
What I ended up doing is I moved all the terms next to each other,
right?
and that's how we found all that. That's why it sounded so weird.
Oh, that's all right. You're getting the right answer. That's all that matters. So it sounds like if I did it in this way, what you did is you subtracted 17x. So this is just the second way. You don't have to know both. And that would give me negative 2x plus 5 equals negative 5.
It's 5.
Yeah. 5 on both sides gives us negative 2x equals negative 10.
And then divide by 2 and you still get positive 5.
Perfect. Now we have a negative divided by a negative, and sure enough, it brings us back to x is positive 5. So you can do this in multiple ways. You'll get the same answer as long as you're following the rules of math and you're doing those things properly. Very, very nice. Did anyone get to number 8?
I did.
You did? What'd you get?
X equals 4.
Correct. X equals 4. Let's work it out just to make sure we feel good.
25x equals 1.
Good. 25x equals 100.
Just divide 25.
That's it. Just divide by 25. And you get x equals 4. That was a short and sweet one. Very nice. Okay, you guys. So today, this was kind of our intro into parallelograms, quadratics, polygons, all of that. It was more of a note-heavy day, not as much of a work-heavy day. So all of that being said, if you would like to stay and get more practice, we can go through more problems. But if you feel good about this, I have your exit ticket ready. And I'm going to excuse you a little early today. We got through our material a lot faster than I thought we would. So that is really, really nice. So your exit ticket, I'm about to pass it out to you. It's going to be a problem just like these. But don't get in the habit of, I know the last 4 were all equal to each other. Sometimes they add up to 180. So be careful. Make sure you know which was happening. Yes, and I have copies of this. You don't have to write it down. I'm just going to show it and I'll pass this out. For your day 17 exit ticket, this is due Friday. You're just going to solve for x. You decide, are these angles equal or do they add up to 180? Solve for x and then you're done. That is all for today, you guys. You don't have to come back after what would be our break time, unless you just want to get some more practice on this. But that's it.